Folks, let's make a start, because then you can get on with the task that I'm hoping you're going to get done today. Okay, so you should be able to see my screen at the moment. Maybe give me a thumbs up, somebody, or say, yes, we can see it. Can you see a picture of a cup, a dog and a hairdryer, hopefully?
Yeah.
You can. Okay, thank you. Somebody's alive. Okay, so key ideas today are about infrared, part of the electromagnetic spectrum. Remember, infrared is just past red, visible light, and so it has a slightly longer wavelength than the red colours that we can see, and we can't see it, but we can feel it. So our skin is sensitive to infrared and we feel it as heat. Infrared waves are heat. And then all of the image that you can see here with these bright colours on have been taken with a camera that doesn't record light, but it records infrared waves instead. So these images are all representing how we would see if we saw using infrared wavelengths rather than visible light wavelengths. Okay, two words we're going to use a lot. Number one, we need to use the word emit, which means to give out, and we're going to use the word absorb, which means to take in. And all through this lesson today, and when you're doing the activity in a minute, you need to think to yourself, is the thing that I'm talking about hotter or colder than the surroundings? Because all objects are doing both of these things, emitting and absorbing infrared at the same time. So at the moment, we're sat in front of our computer or your iPad. You are absorbing some infrared radiation from the room, and you are also emitting infrared radiation into the room, just like this dog is. Okay? Now, if you are warmer than the room, which you are because you're a mammal, and the dog is, and the cup of coffee is, and this hairdryer is, if you're hotter than the room, overall, you emit infrared. You give out infrared radiation. And this is what these images are showing. The colours represent temperature, and the usual thing, if you look at this scale over here on this picture, the hotter something is, the closer it is to white, and the cooler something is, the closer it is to blue. Okay, so if you look at the dog, you can see that the dog is losing heat from its body. It's emitting infrared because it's a mammal and it's warmer than the surroundings that it's in, and it's losing most heat from its ears, from its eyes, and from its mouth. Okay, so we know that dogs pant to cool down, and their mouth is a good place to lose heat from. Its fur is doing a really good job of insulating its body and keeping it warm. Okay, the cup of coffee, look, the handle that you hang on to is the cooler part, and the hotter parts of the mug, yeah, you can see in red and yellow here. Okay, so we can see, if you like, we can look, in inverted commas, because we need a special camera to do it, with infrared radiation, just like we can look with light. Now, your bit of work this afternoon, part of it involves looking at this thing here, which is called a Leslie's cube, and if we were looking at one in the lesson, it would look like this. So you've got a metal box, it's hollow, and it's full of water, and we fill it up with water from the kettle, which obviously is hot. So the important thing is that this cube, this container, is at the same temperature. The contents of it are filled up from the kettle, so the contents are at the same temperature. That means it's hotter than the surroundings. That means it's going to be giving out waves of infrared. Okay, it's going to be emitting infrared radiation from every surface. If we take a photo of it with the infrared camera, which is what this picture here is showing, you can see that the sides are not at the same temperature. Here's our temperature scale over here. This side is hotter than this side. Okay, and it's because the infrared thermometer, it's not measuring. If we stuck a thermometer inside the cube, it would be measuring the same temperature all the time, but some surfaces are emitting, yeah, remember that means giving out infrared radiation better than others. So if you look at this cube, you can see that the dark colored surface on this side is hotter in the picture. Okay, the color of the surface, the independent variable here, the independent variable is the color of the surface. What's different? The color of the surface is it affecting the temperature of the surface? Yes, it is. Why is the temperature different? Because different colors are better at emitting infrared radiation. Okay, and looking at this, you could see that this dark, this matte colored surface here is emitting more energy as infrared radiation, as heat, and we can tell because the infrared thermometer is recording a higher temperature. Now that's important when we come to look at real life things. So I've got 4 images here that you will be able to see. Let's move them up a bit. Okay. So when we're looking at examples at GCSE here, we've got to think to ourselves, why is something the color that it is if it's about heating up or cooling down? Okay. And we're going to remember a key fact. If something is colder than the surroundings, okay, if something is colder than the surroundings, it's going to overall take in energy. Whereas if something is hotter than the surroundings, overall it's going to be emitting heat radiation, giving out. So we've got 4 examples here. Okay, the fridge is cold, the coffee is hot. Okay, the inside of the log burning stove is hot, and the water inside this bag is cold. Okay, and think what we want to happen. We want the fridge to stay cold. We want the coffee to stay hot. We want the wood burning stove to give out that heat to the room. We want it to cool down by giving out the heat energy to the room that it's in. And this is a solar shower, a black bag, fill it up with cold water, leave it out in the sun. Yeah, we want the water inside the bag to warm up. So you can see from the design of these features here, if you want something that's cold to stay cold, we usually make it white. Okay? It's trying to absorb radiation, but the surface is white. That must make it worse, a poor absorber. The coffee is hot. It's going to try to emit heat radiation. So it's in white cups so that it stays hot. That must mean that the white surface is a poor emitter. Okay, now to the two black objects here. The wood-burning stove is black, it's hot, so it's going to be emitting, and we want it to emit. So the reason it's black is because black surfaces are the best at emitting heat radiation. The cold water in the bag is cold, so we want it to be absorbing heat radiation from the sun to warm up. It's about absorbing. Why is it black? Because black surfaces are the best absorbers of infrared. So this sums up our key information about absorbing and emitting. Okay, black surfaces on objects make them better at emitting heat if they're hot, and also black surfaces on cold objects make them better at warming up. So if you want something that's cold to warm up in the sun, paint it black. If you want something that's hot to cool down, paint it black. And if you want something that's cold to stay cold, make it white or shiny. And if you want something that's hot to stay hotter, paint it white. Okay? So you've got your four examples there that sum up what we're talking about. The important thing is this word. Okay? So if something is colder than the surroundings, we need to talk about it absorbing infrared. And if something is hotter than the surroundings, we need to talk about it emitting. Do we want it to be a good emitter or a bad emitter? The cold things, do we want them to be a poor absorber or a good absorber? Okay, now